File and new model. Set the initial settings as you see on the screen. The display units as metric SI units, steel section database as Indian, steel design code IS 800 2007, and concrete design code is IS 456 2000. Enter the number of grid lines in X and Y directions as 4, and enter the spacing of grids in X and Y direction as 6 meter each. So we are designing a 23-story building. So number of stories will be 23. So let the typical story height be 3 meters and bottom story height also 3 meters. Select custom story data and click on edit story data. In our building, stories 1 to 8 will be similar. There are 4 sets of similar stories, namely stories 1 to 8, 9 to 14, 15 to 19, and 20 to 23. These are 4 sets of similar stories. So let us set stories 8, 14, 19, and 23 to be master stories. Story 23 is set as master story by default, so no need to change it. So since stories 1 to 8 are similar, so make these stories 1 to 7 as similar to story number 8. Similarly, make stories 9 to 13 as similar to story number 14. And set the stories 15 to 18 as similar to story number 19. So by default, stories 22, 20, 20, 21, and 22 are similar to story number 23. So let it be the same, no need to change. So just check once if we have selected the right options for the similar stories. So click on OK. Select grid only and click on OK. Firstly, we need to define materials which we are going to use for this design of the building. So go to define material properties and add new property, new material. So select the region as India, material type as concrete, standard as Indian, and grade as M40. Click on OK. Now again add HOST 500. So select material type as rebar and select HOST grade 500. Click on OK and OK again. Similarly, add mild 250 grade steel. Okay. So click on OK to exit. Now we need to define the sections, columns, beams, and slabs. So for that, go define and section properties, frame sections. So add new property. Select concrete rectangular. Change the name to C500 cross 500. This refers to column of section 500 mm by 500 mm. So material is M40 grade concrete. Change the depth and width to 500 each. and then click on modify or show rebar. Here we need to change the rebar materials and design type. So since we are defining a column section, so design type will be for the column, and change the longitudinal bars for HPS to 500 and confinement bar for smile to 50. So by default the clear cover will be 40 mm. Let it be the same. Click on OK. And now we need to define two more sections, column sections of 550 cross 550 and 600 cross 600. So since those sections are of the same property, only the dimensions are changing. So choose the option add copy of property. Change the name to C550 cross 550. So material will be the same. Change the values of depth and width. Click on OK. Similarly, add column of cross section 600 cross 600. Now we need to add a new property by name auto select list. So let's name it as column auto select. This enables the software to choose between those predefined three column sections, whichever is suitable for the design. Design type is concrete, and choose those three column sections. Click on add and OK. Similarly, we need to add beams. So I am adding the first beam of cross section 500 mm plus 300 mm. So now change the design type to beam. Then the longitudinal bars and confinement bars. Click on OK. Oh, need to change the cover. So change the cover to 25 mm for both top and bottom bars. And don't forget to change this material to M40. Click on OK. Let's check. Let me check if I have changed the material property for the column. Yes, that's not a problem. I have changed it. Similarly, add beams of cross section 550 cross 350. Add another beam of cross section 600 cross 400 mm. Just like we added in column auto select, we need to add beam auto select as well. Select those three predefined beam sections, click on add and click on OK. So beam auto select and column auto select have been added. So click on OK. We need to define a slab section of 150 mm thickness. Click on slab sections, add new property, change the name to slab 150, and change the thickness to 150 mm and change the slab material to concrete M40 grade. Click on OK. We can see that plan view is in the story 23. So let's go to story number 1 using the arrow keys. Now select withdraw columns, change the property here to column auto select and select similar stories here. Similarly draw beams, change the property to beam auto select. In the same way, we need to draw the slab as well. Change the property to slab 150 and click on the So we are done with first set of similar stories, that is from story number 1 to 8. So now let's go to story number 9. So okay. Select withdraw columns and draw the columns. So the property hasn't changed. We haven't changed the property. Property is column auto select and similar stories as well. So similarly draw beams. Draw the slabs now. So let's go to the next set of similar stories. That is story number 15. Draw the columns. And beams. Similarly draw slabs. So we are done with the third set of similar stories. We are moving on to the last set. So go to story number 19. I hope no, story number 20. So stories 20 to 23 are the last set of similar stories. So click on story number 20 and okay. So select withdraw columns and draw the columns. Similarly select withdraw beams and draw the beams. And now draw the slabs. Now we need to assign the restraints for the joints. So go to the base, click on OK. Change the cursor to the select cursor, select object cursor and now select all the joints. Go to assign joint and restraints. So change the restraints to fixed restraints. Click on apply and OK. So we have assigned fixed joints or fixed restraints for all the joints in the base. So now we need to assign loads for the building. Go to story number 1. we need to assign a dead load of 2 kN per meter square for the whole building for all the stories. So change the option to all stories from similar stories. Now select all the shells from the story number 1. Now go to assign shell loads uniform. So load pattern is dead, and enter the load values 2 kN per meter square. Click on apply and click on OK. So you can see a 2 kN per meter square dead load has been applied to all the shells in story number 1. Now change this option from all stories to similar stories. Again select all the shells, story number 1. Now we are going to assign a live load of 5 kN per meter square. So go to shell loads in uniform, change the load pattern name to live load, click on 5 kN per meter square, and enter the value as 5 kN per meter square, click on apply and OK. So I have assigned the live load of 5 kN per meter square to all the shells of first set of similar stories, that's from story number 1 to 8. So let's move on to the next set of similar stories. So go to story number 9. Select all the shells. Go to assign shell loads uniform. And the live load for this is 4.5 kN per meter square. Click on apply and OK. Now go to story number 15. Select all the shells. Now assign a live load of 4 kN per meter square. Go to story number 20. Select these shells. Assign a live load of 3.5 kN per meter square. Apply and now again go to story number 1. We are going to use auto draw cladding option in this design. So we need to assign a dead load of 0.2 kN per meter on the exterior beams of all the stories. This is the load coming from the claddings onto the beams. So we need to select all the exterior beams of all the stories. So though the load is same, that is 0.2 kN per meter for all the exterior beams, we can't use that all stories options here because the exterior beams are different for different set of similar stories. So use the option similar stories itself. Now select all the exterior beams of the first set of similar stories, that from story number 1 to 8. So we can see the beams getting selected here. So we have selected all the exterior beams from the first set of similar stories. Now go to assign and frame loads and distributed. So load pattern name will be dead only. So enter the load value as 0.2 kN per meter. Click on apply and click on OK. So we have applied 0.2 kN per meter load for the exterior beams for the first set of similar stories. Now go to story number 9. Select all the exterior beams. Again assign the same 0.2 kN per meter dead load. Apply and OK. go to story number 15. Select all the exterior beams. Assign the dead load of 0.2 kN per meter. Go to story number 20 now. So we need to apply the same load 0.2 kN per meter for the exterior beams of this last set of similar stories. So go to assign frame loads distributed 0.2 kN per meter and click on apply and OK. So now go to story number 23. So the topmost story number 23 will not be having any loads from the claddings coming onto it. So we need to delete the cladding load from the exterior beams of story number 23. Before that, by clicking the exterior beams like this, we are selecting the exterior beams of all those last set of similar stories. So we need to change the option from similar stories to one story. So we are not getting that option here. So go to display, click on undeformed shape. Oh, you get the option here now. Now change this option from similar stories to one story. Now select all the exterior beams of this story number 23. We can see here only the last story, the topmost story 23's exterior beams are getting selected here. Now go to assign frame loads distributed. Select delete existing loads. Click on apply and click on OK. So we have removed the cladding loads from the exterior beams of story number 23. With this, we have finished assigning the dead loads and live loads. Now we need to assign wind loads for this. In order to assign wind load, first we need to define wind load. So go to define, select load patterns, type here as wind, change the type to wind, and auto lateral load, select Indian IS 875 1987 code, click on add new load. Now click on modify lateral load. We have assumed the location of building this 23-story building to be in Bangalore. So as per the code from the maps, we get the wind speed in Bangalore region to be 33 meter per second. So enter that, this wind speed column, and as per the code, from clause 5.3.2.1, so terrain category of Bangalore falls to category number 3. So change it to category number 3. And since the height of the building is more than 50 meters, that's each story being 3 meters, you have 23 stories. 23 into 3 is more than 50 meters. It comes to around 69 meters. So since it's more than 50 meter, it comes under the class C of the structure class. So change it to class C. And from the table 1 of IS 875 1997, we get the risk coefficient to be 1. So let it be the same. And considering the mean life period of the building to be 50 years, we will get the topography factor as, oh no, considering the mean life period as 50 years, also we get the risk coefficient to be 1. And also the upward wind slope in Bangalore is less than 3 degrees. Therefore, topography factor will be 1. So keeping the other settings as default, click on OK. Click on OK again. With this, we have defined the wind load. Now we need to assign wind load. to this building. So let's click on elevation and wait. Now let's go to story number one first. Go to display and deform shape. Select all stories. So one thing we have forgot, we haven't drawn the cladding yet. So let's draw the auto cladding first. Go to draw. Go to draw and select auto draw cladding. Select the use floors option and click on OK. We can see we have drawn the auto cladding for our building. Now let's assign the wind loads. Considering the wind to be flowing from left to the right, that is from section A towards section D. Now go to elevation, select the view from A. Select all the shells visible from section A. Now go to assign shell loads and select on wind pressure coefficient. So from the code IS 875, we get the wind pressure coefficient in the windward side to be plus 0.8. So enter plus 0.8 here. Click on select the windward side, click on apply and OK. Similarly, go to section elevation section B. Select all the shells. Since our uh, buildings is not uniform throughout from story number 1 to 23, so not only section A but also some stories or some claddings from section B are also experiencing the wind pressure from the windward side. So we need to select the shells from section B as well and assign the same wind pressure coefficient of plus 0.8. Apply and OK. Now we need to assign the leeward side wind pressure coefficients. So go to elevation, go to section D, click on OK. Select all the shells visible from the section D. Go to assign shell loads wind pressure coefficient and select the option leeward side, leeward or sides, which is a constant, and the constant value will be, that's the coefficient, will be minus 0.25. Enter the value as minus 0.25. Click on apply and click on OK. Go to elevation section C. Similarly, select all the sections. Assign the same coefficient of minus 0.25. Apply and OK. Now we need to enter the wind pressure coefficients for the sides. So go to elevation, select section 1. Okay. And for the sides, the coefficient is the same, both from the front and as well as from the other side of the building. So let's select all the shells from elevation section 1 and similarly select other shells from other views as well, that is from elevation view 2, 3 and 4. You can see elevation view 2, this is next elevation view 3, so next one is elevation view 4. Go to assign shell loads wind pressure coefficient, The coefficient value is minus 0.8. Enter it as minus 0.8 here. So select leeward or sides, click on apply and OK. So with this, we completed assigning the wind loads as well to our building. So now we need to run analysis on this model. So go to plan, view, story number 1. We can see the wind loads which have been applied to story number 1. So select the 3D view tab, go to analyze and click on run analysis. We haven't saved the model, so let's first save the model with some name. The software is running analysis on the model. We are seeing the deformed shape of our building. So with this, the analysis has been complete. So let's run the design. Go to design, select concrete frame design, view revise preferences. So design code is IS 456 2000, which is right. So click on OK. Go to design again, concrete frame design, and click on start design or check. So we can see that analysis and design sections differ for 705 concrete frames. Do you want to reiterate analysis and design? Since we have selected auto select beam or and auto select column, so the system is asking to reiterate the analysis and design. So if we click as, it will change its preference to the next set of columns and beam sections. That's firstly it has chosen the initial lowest values for the columns and beams. Now it will go to the next bigger section. So click on yes. So it's asking that analysis and design section differ for 10 concrete frames. So it has reduced from 705 to 10 frames now. So I need to keep on clicking on this yes until this notification doesn't come again, so that the analysis and design is okay at that part. So click on yes now. So now if to in order to check if all the sections have passed the design check, now go to design, concrete frame design, and click on verify all. So it's showing that all concrete frame passed the design check. So our design is okay now. Now you can click on any point, right click on any point, any beam or any columns in order to view its design. So it is showing a story 21 beam 5. The values, design values for this beam number 5 for different load combinations. So top steel, bottom steel and shear steels are as follows. Click on OK. You can also see the reports here. If you double click on project report, it will prepare the project report for your model. So you can see the software is preparing the report. You can see the various contents present in the project report. Cover page, structure data, grid data, point coordinates, lines. So the report is now ready. You can see the reports now. So zoom, make it 100%. So you can see the floor base, group assignments, frame section property definitions, and so on. It has all the details, whatever you have done so far. So similarly, you can double click on the summary report as well in order to get the summary report of this project. So we don't have the detailing option in this version of ETABS version 18. So we can't see the detailing diagrams of this model in this version of the ETABS.